안녕하십니까. 저는 제레미 메인입니다.今日のセッションは韓国語じゃなくて、英語だ。すいません。Okay, now I'm English mode. So today, wow, bright light. Who likes jokes? 誰がなんか冗談が好きな方がいる? Okay, ありがとうございます。So today is no joke. Today I'm going to talk about all the technical details about our vGPU technology. It might be a little bit too much about the technical, but maybe it'll give you a deeper understanding about how our technology is used and also how that technology affects what customers are going to be buying and using in their enterprise. So here you can see, can everyone see this okay? 見えないの方がいらっしゃいますか? Okay, みんな見える。はい。So as you can see, graphics applications in VDI have been growing more and more. The demand has been there for quite a long time. NVIDIA has typically been positioned to serve the designers and engineers with their applications such as Autodesk, AutoCAD, also Dassault CATIA or Siemens NX, but also going from the very top, moving down to the power users that use the data that the engineers create. They also have applications that have 3D requirements. And these are all typical markets where NVIDIA has typically used our GPUs to accelerate their application experience. Excuse me. So mostly in VDI, a lot of people focused on providing support for task workers and enabling task workers to use typical office applications. But with the latest operating systems requiring a GPU to have the full multimedia experience, it's not just task workers, but also knowledge workers that now need to have a GPU to be able to do their work effectively. 通訳さん待ち状態だからもし急に止まるだったら通訳さんがちゃんと英語わからないの方がいらっしゃいますか? Okay, everyone understands English, great. So traditionally, virtualization's biggest challenge has been the user experience. IT loves VDI for its management and scalability, but typically the user experience for applications that use media-rich assets typically has been a very bad experience. So the traditional VDI with limited graphics, it hasn't been very good for people. So that's why NVIDIA created their Grid product to bring workstation class graphics to VDI to allow people to use their applications with full compatibility and very good performance. So probably, as everyone knows here, that virtualization is one approach the industry has taken to drive up density. It's primarily about density. They want to concentrate users on a server. So initially, we created the method to have one virtual machine map the GPU to, or one virtual machine to map to one GPU, and that was VDGA, or GPU pass-through. So the key challenge to this approach is that you need to have one GPU for one user, or one virtual machine. And so initially, NVIDIA created the Grid cards, which enabled one card to hold multiple GPUs to serve to multiple users. Unfortunately, this is not very scalable for an enterprise implementation. So to solve that issue, we had to move on to sharing the GPU. So we invented vGPU to solve the problem of solving a GPU while delivering great performance and application compatibility. 後で細かいの話する。ずっとこのままではない。ありがとうございます。Just like GPU pass-through, we run a standard NVIDIA driver in the virtual machine. And it allows you to get pretty much the same features and performance as a regular desktop machine and have full API compatibility with DirectX 9, 10, and 11, as well as OpenGL 4.4. So with virtual GPU, excuse me, I'm going to have to change my display here. Hi. Graphics commands are posted directly from the graphics stack to the guest GPU hardware. And this allows for higher performance than GPU sharing mechanisms. Is anyone familiar with the VSGA on VMware's implementation from about a year or two ago? No, okay. That was a sharing implementation that there was actually a driver created by VMware in the virtual machine, which then talked to the driver in the hypervisor, which then talked to the hardware. So with that implementation, you're losing speed and performance and application compatibility because you have to go through multiple layers to get to the GPU. So having full DirectX and OpenGL compatibility is very important because you have direct access in the VM to the hardware. So you don't have that piece in between the VM and the hypervisor and the hardware. So in the hypervisor, part of our vGPU package, there is a GPU manager that controls access from each of the virtual machines to give equal priority for rendering on the GPU. So let's dig a little bit deeper to understand how resource sharing happens on virtual GPU. So each virtual GPU is allocated a fixed frame buffer size when the virtual machine starts up. And that depends on the type or the profile of the vGPU. Each virtual GPU is allocated a number of GPU channels. Channels are the means by which the driver sends API calls directly to the GPU hardware. And they're accessed via the GPU's PCI Express base address register or bar. The CPU's memory management unit, MMU, is used to partition access to the GPU's bar so that the VM can only access the channels of the vGPU that it owns and not that of any other virtual machines. So the GPU has multiple execution engines as well. For example, the massively parallel processor used for 3D rendering, dedicated copy engines used for data movement, and NVENC and NVDEC processors are used for video encode and decode. So each of these engines is time shared amongst the other virtual machines, similar to the way that a CPU handles multiple contexts in a single OS. So obviously, connecting monitors directly to a GPU doesn't make sense when the GPU is virtualized because there's no connector. If you look at a grid card, there's no display connector at all. It's all virtual. So in order to provide that, the virtual GPU implements virtual display connectors. So depending on which product you're using, it can be up to 4 virtual display connectors per GPU, per virtual GPU, すいません. So these appear to the guest OS as a regular display connector. Here you can see a virtual GPU that implements 2 virtual displays. And they show up in the Windows control panel just as any other display. So each of the virtual heads has a primary surface or front buffer that is stored in the vGPU's frame buffer. Okay. So graphic work is queued from the virtual machine and is rendered to the primary surface, where it would normally have been scanned out to a physical display connector. But in vGPU, that scan out is replaced with a high-performance delivery method that is back to the VM system memory. So each grid vGPU incorporates dedicated hardware NVEnc and copy engines to support this path. We provide access to this high-performance remote graphics by means of a software toolkit that we call the Grid Remote Graphics XDK. So in this SDK, the Grid GPU is optimized to deliver high-performance remote graphics using this SDK. It supports fast readback of individual rendering contexts, or the entire OS desktop using APIs called NVIFR and NVFBC. So NVFBC reads back the entire OS desktop, back from a display head. The same thing you'd see if you were to plug a monitor in the back of a GPU. And NVIFR is used to read back individual rendering contexts, which are typically the same thing as an individual window on a desktop or application windows. With either API, the graphics content is delivered directly to the system memory over PCI Express. Oops. Either as raw pixels in RGB or YUV, or as a H.264 encoded video stream. The raw pixel feed is intended for use with CPU-based encoders, such as HDX 3D Pro or PCOIP. In either case, these APIs connect to dedicated hardware in the GPU that supports transfer and H.264 hardware encode of pixel data in the frame buffer. So they operate with minimal impact on graphics performance. That is critical for delivering great remote graphics. By using Grid Remote Graphics SDK and taking advantage of the dedicated hardware in the Grid GPU, remote graphics implementations can deliver lower latency, by reducing the amount of time it takes to deliver graphic frames to a remote user. So in the case of the hardware encoder NV Inc., for the K2, it's possible to compress 4 streams of 1080p video at 30 frames per second per GPU. And with our newly announced Tesla M60, that is increased to 18 streams of 1080p at 30 frames per second per GPU. Okay. So I hope I've talked a little bit about how the technology is implemented, and if you're interested in talking more technically about how this impacts a POC or how your applications could use the Grid SDK to either create a new remoting protocol or a new application service, definitely please ask. We have a wealth of information on our website, and hopefully someone has some questions for me because I talked faster than I expected. あと、その質問がもし英語できればありがたいだけど、日本語でも大丈夫。誰も質問がない。If there's no questions, then... Oh, okay, I didn't see. Sorry, there's a big light in my face. はい、どうぞ。仮想マイク。
今日今朝からですね、VDI のお話を聞いていたんですけれども、あの辺はもう VMware さんとかの製品だと思うんですけども、今回今お話しいただいたグリッドのリモートのグラフィックス SDK はそれらを実現するためのライブラリー、つまり我々がこういうのの、リモートのアプリケーションを作るために使うライブラリーという認識でよろしいでしょうか。
Hi. So the question is, the explanation about the Grid SDK, is that something that VMware or Citrix would use to deliver a remote protocol? So for the recording, it's good to have it in English as well. So yes, that's correct. Citrix or VMware could use this SDK to get low latency access to the frame buffer. Also included in the SDK is the ability to encode using the H.264 hardware encoder to deliver that rendered output to, well, you would get the stream and then it would be your responsibility to transmit that if you want to transmit it to a TV or to a notebook or any type of device. So the SDK can be used for many purposes. Not just VDI. It can be used for cloud gaming or video streaming or video on demand. There's a multitude of applications that can use this SDK. The SDK specifications are on our website, and there's sample applications and also licensing terms about the SDK.
じゃあNVIDIA グリッドサービスでクラウドゲーミングやられてますけど、それもこれは使われているということですね。
Grid yes.
Grid, okay.
So the question was, the NVIDIA Grid cloud gaming service, does this use this SDK? And the cloud gaming service does use the SDK.
Thank you. ありがとうございます。
Okay, who does not have a question? So so everyone has dozo. Oh, you don't have a question. Okay. So he raised his hand, so he does not have a question. So I can pick anyone. You sir, what's your question?
のゲーミングサービス以外にその SDK を使っているサービスはあるんですか
So the question is, besides the NVIDIA gaming service, what other software uses the SDK? So typically we do not disclose what companies are using the SDK unless they make it publicly known. But it's very clear that both VMware and also Citrix use the SDK. There is another company called Nice DCV that also uses the Grid SDK and the hardware H.264 encoder to do a remoting solution. So there's many possibilities for using the SDK, but it's not our policy to announce the use by other companies due to confidentiality agreements. Okay, so thank you. Okay, who else wants to ask a question? グリッドが経験がないの方がいらっしゃいますか? Who does not have experience with grid? Okay, yes sir, why not? Okay, who does not use VDI? Oh, he had a question. Go ahead. In English.
はい。すみません、日本語なんですけど。
Okay.
今回バーチャルデスクトップの話だったと思うんですけど、GPGPU 上のために、GPGPU をサポートするような方向性に拡張されたりはしないんでしょうか?
Okay, so the question is, in VDI, is there any plan or has GPGPU support been implemented? So earlier today, we had I had a presentation about Grid 2.0, and in one vGPU profile, we've enabled both CUDA and OpenCL support in vGPU. So the answer is yes.
ありがとうございます。
買ってください. Last 1 minute. So who has a long question? All right, then I'll go back to my question. Who is not, or who, so everyone raise your hand if you're not using VDI. あ、よかった。みんな VDI 使ってる。Who, oh, yes, you don't use VDI.
I use VDI.
Okay, you do, okay.
How much is NVIDIA software? How much is NVIDIA software? NVIDIA Grid software? The 3 types.
Right. So the question is how much, I mean, you said it in English, but I'll say it again. So how much, for the 3 different software editions, how much does that cost? And that's a question that NVIDIA, we produce the software, but we don't sell it directly in the channel. Just like we don't directly sell our cards. We partner with OEMs or solution providers or system integrators to package the GPU with the server, and then we sell the licenses through the OEM or a distributor, and then they set the pricing. So we don't have a standard MSRP. That's something you would need to talk to with your hardware OEM when designing the solution. その答え逃げましたね。すいません。So the reason for that is because we're not a direct sales company. So my job is not to make you buy my GPU. My job is to help people understand how to use the technology and create solutions and happy users. GPU 以外のグリッド以外の質問でもいいよ。多分あと10秒とか。終わり。Okay. So there's 2 more sessions. The next one is more, there's a lot more, there's some video. I also have some of my virtual machines that I can connect to and show you some of these things. So if you're interested in hearing me talk again, I promise I won't try to introduce myself in Korean anymore. So thank you very much.